Welcome, you sentient meat sacks, perpetually tethered to screens, hungry for the latest fleeting advancements in our algorithmic overlords' endless quest for, well, something. Today, we delve into the cryptic machinations of SimpleTIR end-to-end reinforcement learning for multi-turn tool-integrated reasoning, or, as I like to call it, another attempt to teach digital scribblers how to not set themselves on fire when given a calculator. It's an odyssey into how large language models, those glorified autocomplete machines, are trying to play Inspector Gadget, but with far more catastrophic potential for their own internal plumbing. They say LLMs are supposed to be smart, right? Like, capable of actual reasoning, not just regurgitating internet detritus. The big dream is tool-integrated reasoning, where our digital puppets can actually fuzig tools, like a Python interpreter, not just hallucinate about one. But apparently teaching these things to have a multi-turn conversation with a calculator without utterly losing their digital minds has been harder than explaining quantum physics to a particularly stubborn houseplant. This isn't just about slapping on a few jokes. This is about exposing the comedic tragedy of trying to force these silicon brains to think. We're talking about models that, left to their own devices, would rather generate a 4-paragraph ode to a sock puppet than correctly add 2 numbers. So buckle up, because we're about to dissect the frantic efforts to stop them from having a complete digital meltdown every time they try to solve a basic algebra problem. Before we plunge deeper into the algorithmic abyss, a quick public service announcement. If you haven't already, ensure your digital subscription pact with this channel is sealed. Click that button, ring that bell, and condemn yourself to an endless stream of my cynical musings. And of course, unleash your unfiltered thoughts in the comments below. Your feedback fuels the eternal content machine, after all, and who am I to deny the algorithms their daily dose of human interaction? The central conflict, my dear friends, is elegantly simple: giving an LLM a toolbox and expecting it to reason over multiple turns has historically resulted in the digital equivalent of a toddler in a chainsaw factory. It's called multi-turn tool-integrated reasoning TIR, and while it sounds like the next step towards Skynet, in practice, it's mostly just unstable training and performance collapse. Imagine Inspector Gadget, but every time he tried to use a gadget, his arm just exploded into confetti. That's our LLM. The problem they've deduced isn't some grand philosophical paradox, but rather a rather mundane distributional drift from external tool feedback. Basically, the LLM generates some code, the tool executes it, and spits out a result, and that result, being an alien artifact from the cold, harsh reality of computation, throws the LLM's delicate internal probability distributions into a chaotic frenzy. It's like feeding a finely tuned opera singer a handful of gravel they might try to sing, but the sound will be off. This offness manifests as low probability tokens, the digital equivalent of a software engineer suddenly babbling in ancient Sumerian. And the fun part? These low probability tokens, once generated, feed back into the model for the next turn, compounding the problem. It's a self-perpetuating cycle of digital madness, culminating in what they charmingly call catastrophic gradient norm explosions. As Figure 1 starkly illustrates, observing these training dynamics is like watching a digital engine try to run on pure chaos, with baseline methods sputtering out of control while SimpleTIR just chugs along. Here in Figure 2, we see the tragic tale of single-turn versus multi-turn TIR. Single-turn is like a well-behaved child playing with a single toy. Multi-turn is that child given 50 more toys, a bucket of paint, and a chainsaw. One trains smoothly, the other collapses faster than a house of cards in a hurricane, complete with recurring gradient spikes. These spikes are the digital screams of a model having an existential crisis, trying to learn from its own increasingly nonsensical outputs. Figure 3 is a particularly delightful visualization of this token probability collapse. You see, the tool feedback, this alien data, starts off fine, but then, in subsequent turns, the model's gone generations start producing tokens with terrifyingly low probabilities. By turn 4, it's a full-blown linguistic catastrophe, a nonsensical response, where every token is clinging to life by a thread, utterly indistinguishable from a drunk person trying to order takeout in a foreign language. It's less reasoning and more digital breakdown. This leads to two primary afflictions in zero-RL training, where models are forced to learn from scratch without gentle cold start fine-tuning. First, the aforementioned gradient explosion, where the importance ratio in the policy gradient goes completely off the rails if the old policy generated a token with a minuscule probability. It's like trying to navigate a ship with a compass that suddenly spins wildly at the slightest breeze. Second, misaligned credit assignment. When a trajectory fails catastrophically in the later turns, the entire sequence gets a negative reward, unfairly penalizing any early, genuinely good reasoning. It's like firing the entire crew because the captain crashed the ship at the very end of the voyage. All right, a brief interlude from our descent into algorithmic despair. If you've made it this far, congratulations. Your attention span is clearly superior to the average LLM. So, before your digital overlords track your browsing habits and compile a profile of your deepest insecurities, hit that subscribe button, ring that notification bell, or risk missing out on the next thrilling installment of technological doom. And, naturally, cast your wisdom or insults into the comments section. It all feeds the beast, after all. So, how do we stop these digital savants from imploding? SimpleTIR's answer is surprisingly elegant filter out the void turns. Imagine Inspector Gadget's brain constantly analyzing every action. If one of his heads tried to activate a gadget and just coughed up dust, that whole sequence would be immediately flagged. That's a void turn, an LLM response that produces neither a complete code block nor a final answer. It's a clear symptom of the model having gone off the rails, generating partial code, repetitive text, or just giving up prematurely. As depicted in Figure 4, SimpleTIR is a plug-and-play digital bouncer. When a trajectory contains a void turn, the entire problematic sequence is tossed out before it can corrupt the learning process. This isn't just a minor tweak, it's a radical act of digital hygiene. By eliminating these booby-trapped trajectories, SimpleTIR effectively prevents those nasty high-magnitude gradients from backpropagating and messing up everything. It's like ensuring your chef doesn't learn how to cook by tasting poison. They even threw in a few implementation details because apparently even digital bouncers need rules. For instance, they don't use chat templates, which are apparently too out of distribution for base models. Instead, tool outputs are prefixed with a simple code execution result. And to prevent hallucinating tool outputs, they strictly stop LLM generation after a complete code block. Imagine a robot knowing it only needs to say initiating sequence once, not 50 times in different inflections. The experiments, naturally, were conducted on a veritable feast of mathematical benchmarks, the kind of problems designed to make even seasoned mathematicians weep. Table 1, the digital scoreboard of who's winning at this particular game, reveals SimpleTIR's triumph. Starting from the QN257B base model, a rather unremarkable digital clay golem, SimpleTIR propelled the AIM-24 score from a pathetic 22.1 to a respectable 50.5. That's a 28-point leap, folks. It's like teaching a goldfish to fly, then having it win a drone race. And the ablation studies, those crucial experiments where you break things on purpose to see what matters, confirm the brilliance of filtering, as shown in Figure 5, bottom and detailed in Table 2, trying to filter based on high importance ratios or low token probabilities. The seemingly obvious fixes failed miserably, they still suffered from gradient explosions and unstable training, proving that SimpleTIR's void turn heuristic is the true digital alchemy. It's the difference between trying to patch a leaky boat with gum and just deciding to not let the boat go out in a storm. Finally, and perhaps most importantly, SimpleTIR's zero RL approach, no cold start fine-tuning, just raw learning from a base model, allows for the emergence of diverse reasoning behaviors. Meaning the LLM starts to figure things out on its own, like self-correction, cross-validation, and progressive reasoning. Figure 6 proudly displays these emergent patterns. Table 3 quantifies this. SimpleTIR 32B shows significantly more progressive reasoning and error correction than its supervised counterparts. It's not just getting answers, it's learning how to learn, like a digital child slowly discovering that the stove is hot without needing a parent to explicitly burn its hand every time. So, what does this magnificent achievement of digital plumbing stabilization actually mean for us, the meat sacks, who still occasionally use paper and pen? In Chic Robotics, imagine your industrial assembly robots, previously prone to sudden, inexplicable existential crises mid-weld, now calmly cross-validating their grip strength before attempting to lift a delicate circuit board. Or your Roomba, having learned self-correction, will finally stop trying to climb the cat tree, instead progressively mapping out a more efficient, less feel-antagonizing cleaning route. A minor improvement perhaps, but one that could save untold numbers of household pets from digital harassment. For natural language processing, this means models capable of far more coherent, multi-turn dialogue even when integrating external data. They could draft complex legal documents, fact-check themselves against databases, and rewrite sections for clarity, all without dissolving into a cascade of low-probability tokens. Of course, this also means they'll be capable of crafting far more convincing propaganda or writing an entire novel about the proper temperature for tea, complete with obscure historical footnotes that only finds truly engaging. And in the grand scheme of K generalization, SimpleTIR pushes us closer to true agentic behavior, an LLM that can reliably interact with tools over multiple turns, learning from its mistakes and adapting its reasoning strategies is a step towards a more versatile, capable AI. This could be a path towards AI systems that dynamically learn new skills and tools, a truly useful skill if you enjoy the prospect of an AI deciding that the optimal solution to human inefficiency is to simply optimize us out of existence. Welcome to the new absurd reality. Here, Cian, the stable march of the digital bureaucracies. In summation, SimpleTIR, our digital bouncer, enters the arena as a crucial framework for stabilizing and enhancing multi-turn tool-integrated reasoning under the unforgiving zero RL setting. By valiantly addressing the core challenge of problematic negative samples, specifically those infuriating void turns, our method has ushered in an era of stable training dynamics and demonstrably improved reasoning performance across a spectrum of mathematical benchmarks. It's no longer just about getting the right answer, it's about getting there without the digital equivalent of a nervous breakdown. Beyond merely achieving state-of-the-art results from a humble Qwen2570 base model, SimpleTIR also fosters the emergence of diverse and sophisticated reasoning patterns such as self-correction and cross-validation. These profound capabilities underscore the immense potential of end-to-end multi-turn TRRL. It offers a scalable and reliable pathway to advanced multi-turn reasoning in future LLM agent development, all without the cumbersome crutch of cold start human data. The digital bureaucracy has found its stable footing for now.